Hi, welcome to our video series covering the features of the toolbox called HyperWorks Lift Ship. In this video, I will be specifically covering the lift manager. This will be actually I'll do a modal and an initial lift setup, and then I'll have one more video for like a turn and a cable contact. So just let's take it in stages here. So in our package, our model package, we have a final mesh. That's the one I will be kind of referring to for the remainder of some of these. I'm not going to do every single one of these turns. I'll do two. I'll do the modal, vertical lift, and then we'll do like a cable contact. And then we'll do some post-processing. Okay, so let's go ahead and drag the final mesh on into HyperWorks. Just give it a second here, and we will dive into the lift manager. So this here is kind of a dedicated workflow just for orienting and setting up the model for lifting purposes. So you can do like a static lift, or you can do kind of like a dynamic where you will model cable contact. So first, let's start with our inputting our gravity. I'll just call this grav 9800. Again, we're in millimeters. And I'm going to do it in the z-axis. So just a note too, when this model comes in from ship constructor, it's in the coordinate system from ship constructor. So the XYZ coordinates for all of the parts kind of goes back and forth. We haven't changed the kind of the location to where it's at, which is why negative z is going to be like our where gravity typically will be modeled. Next will be orientation. So here I'm going to do my initial orientation where I want to kind of rotate it 180 degrees. Just a kind of a friendly reminder, as everyone should know, general best practice is to save your model and at given stages. Here there's kind of just a nice friendly reminder to save in the original orientation and then proceed with kind of rotating it. It could be undone if you're still in session, but just a friendly reminder. Okay, so let's go and click apply. And about the x-axis, it's going to go ahead and flip the model. And this is actually how the model typically is actually constructed and then initially lifted. For this model, we're not going to yet cover cable contacts, but that would be, if we were, that would be part of the next step. And then we do have the crane head locations, so we do need to kind of select those. So in order to do that, let's go ahead and specify those. Either I can do it through, so I can enter an XYZ, if you know kind of relative to your ship constructor global coordinate systems where that might be, you can enter that. Otherwise, we can just go ahead and create them here in HyperWorks. So as this is kind of the initial position, what I'm going to do is go ahead and select these. These would be the lug nodes. Again, holding down Control. Let's go ahead and select those. Box select those. All right, I got all four selected, and hit Control C, Control V, and then we'll go ahead and move those up, maybe 400 units or so. So that's just straight up. I'm assuming that's how the cranes are kind of oriented. And once that's done, we can go ahead and hit Exit. We've kind of created where our crane heads are going to be located, and now we just need to, progressively, call this crane 1. Not too imaginative. Maybe you have some special names for your cranes, and we'll click Save. So let's just go ahead and kind of walk through this. And you might note, as I say Save, that constraint is being created at these locations. So that's part of this automation here. Crane 3. Save. Oops. See, nice little friendly warnings from our developer. And C4, select node. So we did try to include a number of those warnings as you kind of work along the model. So that's our crane heads. And we can move on to now our cable modeling. So here, just kind of note, review the cable stiffness values. So we are going to be generating a C-gap type of element, and we have some property with stiffness information associated with that. I'll talk about that after I create it. And then also, we're basically going to be modeling one cable at a time. So kind of keep that in mind. So let's go ahead and select our crane head node. And for this model, I'll have to do this a few times. And then we'll select our node here and hit create. And you can see that we have our new component and we have our cable created. And it's a single C-gap element regardless of how far you make the crane head, just to make sure that the model is constrained properly. So let's go ahead and select this one. I'll select this contacting node. Say create. So just kind of bear with me here as I walk around this model. Pretty straightforward. This will seem a little more useful when we get to the cable modeling. So I call it crane head. It could also just be a cable, like a cable head if you have like a spreader bar. There might actually be only 2 cranes, so maybe the name could be improved, but the idea is these are kind of like your pick point cables. All right, so now we have, just look at our constraints. That looks good. And those were automatically created during the crane head location. And now we just need to create our load case. So LC1, go and select our SPC, select our gravity, and go ahead and click save. So before I do that, I want to make a note. When I click save, I want you to note kind of in the model browser here what gets generated. So let's go and click save here. We're going to import cards for output requests, control parameters, screen outs. Basically, this gets automatically set. We're going to import a variety of load step inputs for a nonlinear analysis to ensure that we're kind of capturing that nonlinearity of the cable, and we'll generate the load steps automatically. So all that gets generated from this lift manager. If I don't like it for some reason, I want to rename it, you can just simply click delete and then kind of recreate another one, new case, something along those lines. In this case, if I wanted to preliminarily run a free modal analysis just to make sure that the structure is behaving correctly as a whole, maybe want to verify contacts, verify parts are properly connected, etc., which technically should have been done already through the topology review and contact review. But in those rare cases, you might have some parts flying up. We create that free modal analysis. Okay, so in any case, we'll go ahead and select our SPC and our grav, go ahead and click save, and there we have our load case. So there's our normal modes. And again, it's free. So this model is set up and pretty much good to go. I'll cover that in the next video where we'll talk about job submission and management. So in the next video, the very next one, we'll cover cable modeling, and then we'll get to the job submission. So again, that'll conclude the video. I hope you found this helpful. Please leave us feedback on the Altair community forums.